Rates of change. Why am I not using my notes? Because I saw, okay, I was trying to record with it. I do not like it. I have some big mistakes. I do not know how I did it. I think it's because since I was burnt out at the end, I did not have the time to see what on earth even did I even write. Okay, I did some working the correct way, but because of how I define the functions, that makes it very confusing to follow through with my explanation and the actual writing. So I will rewrite them again in here so you guys can understand it. What are rates of change? Okay, change. Here is the example. You have a function y. You have a function y which is a expression. Okay, y of x. Y is equal to f of x. Y is a function of x. Okay, what do we see? Y is a function of x because y acts like a function. You know how f of x is equals to expression? Y is equals to that expression. So doesn't y get the right to have x as its parameter technically? The value of y depends on x. So that is why we say y is a function of x. Now, what if I told you x is also a function of another variable, example t. X is a function of time, t time. Okay, it would be something else like radius, height, etc., area, volume, surface area, and this stuff and that stuff. Mensuration. Okay, you would use this likely in mensuration, but it would also come up as abstract ideas. Okay, we will do past papers after this theory stuff. Then I will teach. Now, here's the question. What if you want to find the expression which tells us y is a function of time? How do you do it? We know y is equals to f of x. What is x? X is equals to g of t. So let's go plug it in. Plug in gobar a. And what do you get? Y is a function of t. How? It is a composite function. Y is a composite function of t, or a new function h, where h of x is equals to the composite function f of g of x. Okay. So to recap, we know the line y is equal to f of x means y is a function of x because y has the right to act like a function because the values of x that we input, it changes the value of y. So y has the right to be a function of x. Similarly, as we input the values of t, x changes. So x has the right to act as x of t. Okay, x is a function of t. Now, if we want to find a thingy that tells us that y is a function of t, what do? Since x is a variable, we literally plug in x here, and you get y being a composite function, which you can figure out, combine it, and get a new function h of t, where we say y is a function of t by it being represented by each function. Okay, the function h, and here h is the composite function of f and g. If you do not know what a composite function is, go back to the functions video. Now, we know all this good stuff. And what good stuff do you also know? Derivatives, my favorite. Derivative is saying y is equals to f of x. What is the derivative? Derivative is the rate of change. Y prime is equals to f prime of x is equals to dy over dx. Okay. Now, this is rate of change. What do I mean by rate? Rates of change. Rates of change. Well, this is where we want to find the derivative of y of x, y of t. Y of t. We know y of t is equals to f of g of t, a composite function. What does it even mean to find dy dt of this? What is this? We do not know how to take the derivative of a composite function. Do not worry. I will tell you how to take the derivative of a composite function. You know that the derivative of y, would be f prime of t, f prime of x. The derivative of x would be g prime of x. G prime of x. What if we want to combine it? What if we want to combine it? You want to find dy dt. Dy on the top, dt on the bottom. What expression has dy on the top? Like a fraction. Yes, dx. Dx. If you multiply this by dt, dx by dt, you get this expression. Now, we have solved the puzzle, but we have not solved the confusion. Why on earth does this work? Well, it uses the fact that you know how you cancel out units in rates, like kilometers is equals kilometers an hour is times hours 3600 seconds times 100 meters over kilometers. This then turns into what? This turns into meters a second. We cancel out units. Okay. This is a bad example. This is speed. If you multiply it by hour, then you get a distance. We cancel out units. Okay, we cancel units. We do the same thing here. We cancel out rates by using rates, basically. If we want to find this, how much distance? Okay, if you want example, we know the rate of speed, the speed at which a object is going, and we know that the faster you go, okay, the longer you go, the more temperature it increases. Okay, the more distance you cover, the more the more time you are in something, the temperature increases. Example, you are in like a sauna for 2 hours, so it increases by a degree Celsius. Okay, 2 hours a degree Celsius. That's called as T. We want to know by how long should we move in a sauna such that we change we increase our heat by 1. So we cancel out the time, we get the quantity Vt, kilometers a degree. Kilometers a degree. Okay. Distance over temperature. Okay, we can call it meters meters over degrees. Okay, Vt meters over degrees. Okay, that's the example. Okay, cancelling units. Here we do the same thing. We cancel units. Technically, this represents the rate, the change in x, and this represents the change in y and change in time. If we cancel out the change in x, we get the change in time, change in y. This is why it works. Okay, it's a cancelling units but on steroids. Let's see some questions so that we can properly understand this. Variables x, y and t are such that you know y is a function of x, and we know the rate in change of y, a rate of change in y over rate in change of x is equals to 10. Find the value of dy dx and x is equals to pi over 2. This is simple, just plug it in and boom. Find the rate of x over the rate of time when x is equals to pi over 2. How do you do this? What do we know? What do we know? We can easily find dy dx in the first part. The first part, we know dy dx is equals to what? We know this value is -5. Okay. Now we know dy dx. We want to find dx over dt. How do you do that? We know two things. Dy dx and dy dt. Dt is in the bottom, so we know dy dt is this. You want dx on the dy in the bottom. What do? We fix that. We do inverse of this. We flip this fraction literally. What do you get? Dx over dy of an at pi over 2. What do you get? -1 over 5. So we do dx over dy at pi over 2. So let's do this. This is 10 times -1 over 5, -2. Dx dt is equals to -2. This is basically abusing on steroids. Like I said, we find the rate in change of y in as x is equals to pi over 2. Okay, only we know how much y changes as x changes by the equation this. We plug in pi over 2 and we know that at pi over 2 y changes by -5. Okay, we find the reciprocal of this value, that as x changes, y is at y is equals to pi over 2, it is equals to -1 over 5. Okay, I can talk about this but not going to. Now we want to find how much does x change by when t changes. At what value? Pi over 2. We know y is a function of time and y is also a function of x. They are like related. Okay, we want to have the best relation ever. So what do? We relate them, obviously. We find a linear relationship of y of x. Okay, we know y of t. We want to know t of. We also know y of x. Okay, y of x. We basically turn this into x of y illegally. Okay, by flipping this fraction over here. Okay, we know this the rate of change of this. You haven't completed the inverse function. You just have to complete the reciprocal of a rate, basically. Okay, if you do find out the inverse and then find it, you can get the same output. Do not worry. Okay, it just saves time. Next, we know y is a function of time. So you plug this in, we find x of y of t, which is basically what? Y is a function of time. So you can say x is a function of time ultimately, and this is why we find x dx dt by just multiplying. Okay, I hope you get it. Let's solve a few more and see. This is a fun one. Mensuration. The diagram shows sector OPQ of a circle centered O radius R, where angle POQ is equal to theta radians. The perimeter of the circle is 10 centimeters. So show that the area is given by A is equal to 50 theta times 2 plus theta squared. We know something. You know the perimeter of the sector is 10. Perimeter of the sector is no. This is a boring question. Okay, I just found out. Wait. Okay, yeah, change it. Okay, sorry. You can identify when there are three variables and three things are working together. A closed cylinder has the base radius R, height h, and the volume v. It's given that the total surface area of the cylinder is 600 pi and the volume v, radius h, and h can vary. So that v is equal to pi 300 pi r minus, oh my god, I can't even read equations. We know v is equal to pi r square. We know surface area is this expression over here. Given that this is 600 pi, we want to find h such that we can plug this back in and find the volume in terms of r only. So we have this expression here. We divide everyone by pi because who like wants to keep pi. So we shift this over there. 600 minus 2r squared. We divide everyone by 2r, and this equals h. Simplifying, this is 300 minus 2r squared r over r, and we plug this inside back into the equation of the volume. Okay, plugging this back in, what do you get? Pi r squared 300 minus 2r squared all over r. Now pi r squared 300 over r, this evaluates to 300 pi r like we said earlier, minus pi r squared 2r squared over r. And these to cancel. This evaluates to what? Something I do not even remember. Okay, yeah, this is much normal r. So this is pi r cubed. Nice, we've shown that it is indeed equals to that. Free 1 mark. Final station. Oh my god, bruh, I did all that for nothing. Fun one. The radius r of a circle is increasing at a rate of 5 centimeters squared. Okay, so the radius r of a circle is increasing at the rate of 5, and this find in terms of pi the rate at which the area of a circle is increasing, and r is equal to 3. What? Okay, we know the area is equals to area is equals to pi r squared in centimeters squared. Okay, centimeters squared. And we know at r is equals to 3, a is equals to 9 pi. Okay, a is a function of r. Now, as we know that r grows by time, okay, dr dt is equal to 5 for some value of time. Okay, for that time, r is equals dr dt is equal to 5. We know a of 3 is equals to 9 pi. But no, what do we need to find? What do we want to find? dA over dt. Yes, it's actually asking us to find this. How do it? We want to find, we know the rate as the area increases by r. Yes, the rate area increases with respect to r, and you multiply this as the radius increases with respect to time. Doing this, the r's these cancel out, and what do you get? Now, this needs to be this is a fraction. This is a value. You cannot leave this b. So what do? We know that the dA dr, okay, a is equals to pi r square. dA over dr is equals to 2 pi r. See something? This is the surface area. No, the perimeter formula. At r is equals to 3, this equals 6 pi. At r is equals to 3, this equals 6 pi. So this is what? 6 pi times 5. 6 pi what? 6 pi centimeters times centimeters over seconds. So we find centimeters squared over second, which is indeed works out is equals to 30 pi. Very easy. We know the volume of a sphere is given by V is equals to 4 over 3 pi r cubed. You know r is a function of volume. We know the rate at which r increases with respect to time is what? 0.5 centimeters a second. Find the rate of change of volume when r is equal to 0.25. What do we need to find? We need to find the rate of change of the volume with respect to time. What do we have? We have the rate of change of the radius with respect to time. What do we need? The rate of change of volume with respect to the radius for now. So what do we need? This value. This is a number on its own. So this is what? 0.5. This is not a number. This is an expression for now, an equation. So we know V is equal to 4 over 3 pi r cubed. If we differentiate this, dV over dr is equals to what? The surface area thingy. You can watch 3 blue 1 brown about like circles and stuff, circles in like more dimensions. The one video where he said your balls are puny or something. Yeah, you can see why how he discovers this cool relationship. Anyways, we know if you plug in 0.25. Okay, let's plug in 1 over 4. You get 1 over 4 squared. 4 pi 1 over 4 squared. This 4 cancels out. So we know dV dr is equals to pi a quarter pi. So what do? You do a quarter pi times a half. What do you get? An 8 of an pi. Nice. I hope you understand what I did. It is given that y is equal to tan of 3x and y is over sine of x. Now this has asymptotes as its breakfast, but find the exact value of dy dx when x is equal to pi over 3. Differentiating, what do you get? Tan of 3x is equal to 3 secant squared of 3x minus, no, this times sine of x minus tan of 3x sine cosine of x all over who? Sine squared of x. Now we want to evaluate this at pi over 3. Let's go. So pi, evaluating this at pi over 3, you get pi. What is secant squared? It is 1 over cosine squared pi. Squared pi. Now this is the same as cosine of pi, and pi is 180. The x would be -1. Yeah, this would be -1. So -1 squared is 1. So this evaluates to being 3 times sine of pi over 3. So this is pi over 3, which is like 60 degrees. 30, 60, 90. If you do some of this shenanigan, this is 1 1/2 and root 3 over 2. So this is sine of x, so that means it is root 3 over 2. Now this is tangent. We know sine is 0, so 0 over -1 is 0, so 0, and this remaining is 0, so 0 0 0 0 0 0 0 0 0 0. Okay, this is root 3 over 2 squared. Now simplifying this further, what do you get? This is 3 over 4 on both sides. You get 3 cancel out, so this is what? 2 root 3 basically. Nice. Correct. Hence find the approximate change as y increases, blah, blah. No, this is not in today's video, on today's agenda, so sorry about that. We know y prime of pi over 3 is equals to 2 root 3. I still have the monster equation, don't worry. Given that x is increasing at the rate of 3 units per second, we know what do we know? Dx over dt is equals to 3. Find the corresponding rate of change in y when x is equal to pi over 3, giving our answers in a simplest third form. Okay, we want to find dy dt. We know what? Dx dt. And what do you also know? Dy over dx. So if we multiply, we find this. Now evaluating this function at pi over 3, what do you get? 2 root 3. 2 root 3 times 3 is equal to 6 root 3, and that is our answer. Nice. Guys, can I please do this question? Come on, this one, please. Okay, then we are continuing. Okay, then yay. Find the expression, we need to match it somehow. 0. If we differentiate g twice, we get 0. Okay, good, nice. We get a free pass. So you can only use this I don't know how many times. 4x, and this is f prime. Nice. Ooh, this could be found by 2 times 2 times 2x plus 1 squared. This expands to 4x squared plus 4x plus 1. Yes, so this is fg. This is fg. Weird way, but some way. 8x squared plus 8x plus 2. Nice. What do we have? 4x plus 3. How on earth do you even get that? We got 4x What's needed plus 3? Or do we have g squared? Gf, g double prime. Inverse. Ooh, inverses. Wow. Inverse, they won't do much. Yeah. This could be gf. I'm hoping. 2x plus 1. This is 4x squared plus 1. No. Dude. Okay, this last one here is g prime, inverse of g. Which expression gives us 4x plus 3? We know it's not f prime, it's not f double prime. That would be 4 g prime. We have used it. G double prime, we have used it. Gf is equals to 4x squared plus 1. F squared, this is 2 times 2x squared, this is 4x to the 4. G squared, 2x plus 1. Ooh, g squared, nice. Okay. Yeah, thanks for the pit stop. Let's continue. Y prime, it's prime time. I want to do this in another way. I want to find the natural log of 2x squared plus 1 times x plus 2 to the negative 1 power. Doing this, what do we get? A few factors. Differentiating this, we get 2x squared plus 1 times the derivative of this, which is 4x times x plus 2 to the negative 1 power plus natural log of this times the prime of this. So we know this is a composite function. Yeah, that this is g of x. Oh my god, let me explain it to you guys. Never mind, no. So differentiating this, we get this because the derivative of 1 is 1, so 1 times 1 is 1, and all that good stuff. No, wait. Aha, there we go. Yeah, 1 times negative 1 is 1, so yeah. And this is the derivative. We want to find when x is equal to 1, the rate of y and t. When x is equal to 1, dy dt is equals to 3. We need to find dx over dt. What is this? This is dy times dt times dt over dx. No. We know dy dx. If you swap dy dx, what do we get? Dx dy. And we can get what? Dt, no, dy dt. This is a variable and this is a expression. We know this stuff. Dy dx is equals to this expression over here. Wait, let me fix this. Nice. And if we plug in 1, we get 4 over 2 plus 1 is equal to 3. X plus 2 is equal to 3 minus 1. 4 over 9 plus negative 3 to the negative 2 minus 1 over 9, which is what? 3 over 9, which is what? Tell me, what is it? 1 over 3. Nice. So this is 1 over 3. But swapping it, what do you get? 3. So the overall value is 9 because it's equal to 3 times 3. Nice. Y is equals to logarithm over a polynomial. Find d by dx when x is equals to 0. No. Wait, I swear I found. Yeah. No. Yeah. It is given us that blah 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 when x is 1, y is. When x is 1, this is 6. 3 minus 1 is 2. Minus 1 plus 2 is equals to 3. Negative 2 is equals to what? 1 over 9. So this is 3 minus a ninth, which is what? 26 over 9. 26 over 9. We know y is increasing at the rate of each units per second. dy dt is equals to what? Each. Weird, I know. Find in terms of each the corresponding rate of change in x, in your values, giving your answer in exact form. We know dy, we want to find dx dt. What do we know? Dy, no. We know dt, dy dt. We know that dy dx at 1 is 26 over 9. If you flip this, what do you get? Dx over dy. So you can cancel it out and get dx over dt is equals to 9 over 26 each. Very good. Okay, I'm very sorry for this. Okay, I accidentally skipped this one of these terms. Okay, now I'm recalculating it. Okay, so and dy dt is equals to 3 dx over dt. So you know dy dx. So this is what? So this is 9 over 4 minus natural log of 3 times 3. So you get 27 over 4 minus natural log of 3. Boom. Evaluating this at 1, we get 6 times 3 over 3 minus 1, which is 2. 6. So this is 3 times 3, this is 9, minus natural log of 2. Natural log of 2 over 9. So this is 27, and this is this. So what do you get? We get a good value. 9 minus natural log of 2 over 9 each. Nice. Next, y prime is equals to x 2x e to the x squared x minus 2 to the negative 1 plus e to the x squared x minus 2 to the negative 1 into the negative 2, and 1 times 1 is 1. So nice. Evaluating at 0, what do you get? We get y prime of 0 is equals to 2 0. Okay, so 2 0 e to the x squared, so this is 0, plus e to the 0 squared, 0 minus 2 negative 2, this is obviously 1. 0 minus 2, so this is negative 2 negative 2. So this is what? This is 1 over negative 2 d squared. This is 1 over 4. Nice. 1 over 4. Y is increasing. Okay, dy, we know what? Dy dt is equal to 0.5. Find a corresponding rate of x. Oh my god, 5%. Okay, what do we need to find? Dx dt. So dx dt is equals to dy dx. No, we want to find dx dy times dy dt. So this is x over y. So this is actually 4. We flip the fraction, and this is 0.5. It is what? A half. We get a value of 2.